All right, let's begin. For my Twitch viewers, thank you for being here and hanging out with me again on this afternoon, this Saturday afternoon. Getting ready to brave the big old snowstorm that's going to be tearing through. So hopefully everything goes okay with that. I wish all of you guys good luck and you stay safe out there because it could get bad, and especially down south with that ice that's coming through. Here we're just expecting snow, but we're kind of used to that up here in Ohio. So just stay safe. To the YouTube viewers who will be watching this after the snowstorm has passed, I hope everything went well, and I'm glad to see that that everything's okay and you're checking out the videos. So. Yeah, it might be a mess. Might be a really big mess. So yesterday we pretty much finalized as much as the final testing as we could, without having better test fixtures, a better path for how we want to go about doing this. We need something to really kind of push the system, make it work, actually use it, run it in a sort of real kind of application. And they kind of gave me some ideas of what we're going to do, the direction we're going to go in, and kind of the out-of-box kind of experimental firmware that's going to be kind of included with it. We'll start writing all that as part of this. So I figure, what the heck? We're going to go ahead and start working on a bunch of different things. One thing is to design and throw together the test fixture to test those TPU belts. Because why not, right? So I've got a bunch of stuff coming in, some extruded aluminum, some other miscellaneous parts to help suss that out and get that built. It's not going to be perfect. It's going to be a little test fixture. But we're going to throw in a bunch of different firmware on this. And, it's going to do something. Basically, we're going to have... So the principle of operations, we're going to have basically a control switch, basically a start-stop, an on-off, basically. We're going to have two limit switches, basically catching, both of the inputs, basically the extensive travel. And then I'm also going to throw an RS-45 console, because one of the things I want to kind of play around with is, so since we can try to do this... I want to be able to maybe turn this into the firmware that ships with it, because we're going to put everything. We're going to suss all this firmware out and get something solid out of it. So we'll have RS-45, and I'm going to run. So my office and my workshop, I'm in the basement, and I pretty much have half the basement to my needs, to the workshop and my office. But the workshop and the office are kind of separated by a wall between them, which makes it nice. I can keep each mess isolated from each other. But I have some cable. What I'm going to do is I'm going to run a 3-conductor cable. We only need 2, but a 3-conductor cable across the wall from my office to the workshop. And we're going to tie into the RS-45 port. And I'll be able to kind of check the status from my desktop here, so in the office. So I'll be able to verify the RS-45, kind of do some playing around with that. That way, we could validate and have some example firmware for the RS-45. So I think that'd be kind of cool, and it'd be a practical example of what you could do with it. RS-45 has some insane distances that you can travel with the cables, and if you do things right, you can even get resistance matched cabling and dial everything in and get some even more insane lengths off of RS-45. And realistically, if we wanted to, we could have another one and set it up more sophisticated to each board having its own individual address. And we could just basically talk to a specific board if we really wanted to, but we're not going to bother with that, because RS-45 is basically supports multi-drop. Multi-devices on the same bus. They're just in parallel together. And as long as you've got a methodology for addressing individual boards, they can all share the same bus, and only the one you're talking to will respond back. So it becomes a controller / peripheral type relationship there. So that's what we're basically going to do, is just, we're going to kind of use that, suss out full firmware. That's going to take a little bit of time, suss out the firmware for the temperature sensor so we can get statuses. We can have the fan in here, have all of it. Even the FTDI interface, the debug interface will have firmware for that. We'll have all that. So we're going to suss all that out and work on it together. But I thought, and then like I said, I've got the parts coming in for the test unit. I got to, so the first belt we're going to test is going to be basically TPU for AMS from Bamboo Lab. And I like it. It's more rigid than standard TPU, but it prints these belts pretty good. So that's the first one we're going to test. Because I already have the TPU. I know it prints. I've already printed a belt, and I think I've already accidentally thrown it away during one of my cleanups down here, trying to get things better organized, because I eventually do want to get some webcams and show my ugly face to the world. I don't want to be a completely faceless YouTube channel and actually showcase more of my office / workshop. But I really need to organize it a little bit better. It just takes a lot of time, and considering, having a real job, full-time job on top of this, it's just time consuming. But that's my end goal, is to actually be able to have more cameras, more interaction with the audience. So you see I'm a real living person. I'm not some AI, sexy AI voice or anything. So today what we're going to do is we're going to kind of shift gears a little bit, because I don't want a bare board just flopping around, possibly shorting out. I want to be able to mount stuff. So what we're going to do today is we're going to start designing the enclosure for the board, the 3D printed enclosure. We're going to use Fusion to design it in, and we'll just print it out 3D plastic. With right now PLA, we might go with an ABS down the road for final production, or maybe a nylon or something. Who knows? We might go with like a reinforced nylon from Bamboo. I prefer to stay within their ecosystem for their filaments, because they control everything. They control the quality and all the dimensionals and all the tolerances and all the materials that go into their filament. So it's just easier to stay within their ecosystem for me. And I'm just going to put that out there for well over a decade and a half, 2 decades. I've had a 3D printer that I built from a DIY kit. I bought one of the major, when the RepRap printers really started getting out there, all these companies started making all these like DIY kits with extruded aluminum, laser cut wood framing and stuff for them. I bought one of those DIY kits, and for about almost 20 years or thereabouts, I mean quite a few years, at least 15 years, I've upgraded that thing. I've kept it. I've nursed it. I've upgraded the firmware, modified the firmware, and made that thing do things it was not originally designed to do. It became a Franken printer. I learned a lot about 3D printing, how G-code works, how these systems work, which was great and all. But to be honest, for anybody to say, oh, you sold out, you went with a commercial printer, Bamboo. I'm sorry, I gotta say it. It makes my life easier. And they did a bang-up job with their printers. And after the hassle of trying to keep a DIY printer going, having to keep adjusting things, keep fixing things, it just gets to be a hassle. When it just got to be a hassle, when all I want to do, design, push a button, print the thing out, I don't have to sit there and piss around with my printer. So that's why I just went with a Bamboo Lab. It's a great printer. I've got the X1 Carbon. I really like it. I'm planning on buying one of the smaller A5s, A3s, or whatever they are, for more prototype building. It's not enclosed or anything, but I could use it for, parallel printing other parts or doing more rough draft prototypes while I'm printing the more serious parts on the carbon. I really like it. I mean, you know, again, I'm not sponsored or endorsed or anything by these guys, but I like their printer. It's really good. I just got so tired of the hassle with the DIY printer. It just became too much of a headache, too much of a liability for me. And it just having to fix something that goes wrong every time I want to print or struggle with TPU. I just got tired of that fight. So we're going to design an enclosure. Right now it's going to be PLA. We're going to do the TPU belt. So the enclosure is going to be 2 parts. So I'll have a main, basically a tray that the board will sit in. And then I'm going to hold it down. So we'll have heat set inserts, M3 size, in the bottom of the, basically in the bottom of the tray to actually hold the board down. But it's not going to be held down with screws. So what I'm going to do is I'm going to use, I have 20 millimeter brass standoffs that I use on another project, and these things are great. I love these standoffs. And we're going to use these brass standoffs to hold the board down into the tray, but to also allow us to secure the lid to the whole assembly. So it'll simplify the design, simplify the BOM, and simplify the printing. Because then I can print everything out in two parts. So the first thing we got to really start working with is the PCB. Get the board in here. Well, get the core design. So I have Fusion open up. So let's go here. So we've got Fusion. So there's one of 2 ways we can do this. We can just kind of just go with it, just pull the dimensions out, which is probably what I'll do. I'll just pull all these dimensions because I have all the dimensions here, and we'll kind of design the enclosure around the dimensions. One of the other things I think I could do is I could actually view this. I think I could 3D view this board. And I think I can, even though I don't have the components on it, which is kind of sad because, again, I moved the directory and I need to go and update all the libraries to have all the step files back. But I think I can export. No, I can't. I wanted to see if I can export. Maybe I can't export. Let's see if I can do it out here. Tools. Huh, maybe I can't. File. Okay, I could export the board as a step file. And then I can import that board into let's go through here. Let's just see what we can do here. Grid origin. Board center origin, not. That'll send the board, which is fine. I don't really care. We don't really export the components. All we really need is the board. It's going to throw it there. Okay, so it's going to throw it in the project directory. Just throw it out here. Or project outputs. Oh, you know, it might have pushed it in this guy. No. Where did you save it? I just saved it here. Oh, right there. Zip file. So let's try this. What the heck? We're going to file. We're going to import. Done this before. insert. Maybe we can just open it. File, open. I thought there was a way to pull that in. All right, so we got the board. All right, that's fine. Okay, let's kind of orient ourselves. Okay, yeah, sorry, there's a USB connector. All right. RS-45. We don't have the components, which is fine, but we should have the board dimensions. Okay, so that might actually work. All right. Okay. Guess this is what we can do here. All right, so at the top, at the bottom. Okay, so we're going to create a sketch off of this guy. So I guess the first thing we should do is, since we're at the bottom, kind of... there we go. Let's make life a little bit easier. Kind of... I don't know how much of a pain in the rear that will be, but hey. Diameter. Okay, so we're using M3 inserts, so we need to make sure that is more than big enough to hold it. Let's go. So the outer diameter is about 4.15, 4.18. So we need to make sure we have enough plastic. So about 8 millimeters. So what we're going to do then is... Don't know how this is going to work out, but we're going to try it. I really... If I could have just inserted the board, it would have been easier. But this at least allows us to kind of build off of this guy. Now, we need to figure out how high we need it to kind of stand off. Because we have the through-hole parts that poke through. You see, you're about 3.84 millimeters. So let's go about 6. All right. All right. Okay, that will not work. That will not work because of the because I don't want to attach it to that body. I do not want to attach it to that body. Oh. Well, let's figure this mess out together. Yeah. Let's hide this. So let's just create right here. Let's just do this. Let's kind of... Now let's show this. Okay. All right. So we can move that up on top of that. And then Z, we can go kind of move it up on the Z axis. Okay. Select the body. Move. There we go. All right. Okay. So that's what we can do. We can just kind of make minor adjustments, minor tweaks to it as we go, and that will be perfect. So let's go back here. So that way we have two separate bodies when we do the extrusion. We'll hide that for now. No, let's keep that active. Let's go back to this guy. All right. So new. All right. So I know where that origin is. Can I move this back here at the end? Yes, I can. That way. Ah, yes. Okay. All right. So we're gonna have to do some playing around. So I wonder if we could. Driven. I guess all we can do is kind of start playing around with some ideas here. It's gonna be a lot of fun to figure this out. But we'll get it. Let's get in there. So now we have our dimensions of 120 here. So we know we need a minimum of 120. We'll want our walls, let's say our wall thickness to be 1.5. Oh, all right, let me grab a pen so I can keep track of all this. So we know we have 120. Let's see, other dimension, 85. So we want our walls to be 1.5. So it's going to be an additional 2 millimeters. And then we're going to want kind of like a oops factor of maybe 0.25 millimeters on each side. To help for account for any tolerances on this. So So what we're going to do is we're going to do this. So it's 120 plus 2 millimeters, so it's 122 plus 0.5, 122.5. And this guy will be 87. No, actually, I did my math wrong. My bad. 1.5, 1.5, 120, 123, 123.5. My bad. 85. Also, I can do this. $88.5. All right. So that should account for an oops factor. And we're going to go ahead and extrude this 1.5 millimeters. Or maybe we'll make it a little thicker. Maybe 2 millimeters. Basically 1/8 of an inch thick. Let's just give it a little bit more heft to the base. Because so the idea then is to now actually what we can do. Okay, so we've got that. Let's go ahead and that up. Let's put this guy in here. Just for that. Right. Now let's. So we got that. Can I get these guys in here? In the rear. Because those will come up to there. But I'm going to need that to be a different height. Yeah, this is going to be a royal pan in the rear. So let's do this separate. That way we can kind of control things a little bit more. Finish the sketch. Let's kind of grab this. So at the end of the day, we need that guy. So I'd say probably about 5 millimeters to give us enough enough height. Actually, I probably could have thrown those guys in there. Cancel. Get rid of that. We're going to say 5 millimeters. Yeah. Boom. All right. We can make that a little bit beefier. That's fine. We'll see. We'll see how much we have to clean that up. Because we're going to do a bunch of other stuff to clean it up as we go. So this might be a multi-part series, multi-video. We might have to finish this up tomorrow because this isn't something that, that we could really. So, to dimensions kind of figured out here. Actually, no. We need to go for the outside, because if I don't count that, I'm going to screw myself over. Okay. So we need to turn 8.25. So that should be the edge of the board right there. And then those are what? Those are 5mm in from the edge, the centers. 13.25. All right. Let's try to find this out. Let's see. Again, I know there's easier, probably faster, smarter ways of doing this, but this is the way I work. I started working with FreeCAD at first when I got into this. Great package. I really got pulled into Fusion when, so I had originally bought the perpetual license to Eagle when it was owned by the other company. And then Autodesk bought them out and went on a subscription model for like $15 a month for Eagle, but you got all these great features. So I went ahead and went with it, and they wrapped Fusion into it. So or Fusion 360 at the time. So I started working with the Fusion, and I've loved it ever since. And I just decided to stick with it. All right, so we need to show that sketch. So we're gonna come up at least. Get in there closer. Millimeters. All right. So we're gonna show this fella. Way off. Well, that's good. Good to know. All right. Oh. Right. See. Millimeters. We'll eventually get this guy dialed in. That looks close enough. No. .5. Ah. Right. That's what that does. All right, perfect. Now let's move it back the other way. 5. All right. All right. Hello? No, no, no. Go that way. That way. Okay, so I see we need to kind of go back a little bit. Just back to measure. All right. 2.127. Two point 564. All right, grab my calculator so I can figure out the difference and kind of nudge it back just a little bit. Two. Oh, get out of that. That. I'm going to move x minus 0.2185. Then, if we are right, 2.282. You're gonna do this to me. You're gonna fight me. Okay. Okay, let's try moving you one more time. Move 0, negative. Nah, 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 nah. 2 point. So if we get this dialed in, we just kind of like leave everything alone. 2.351. Maybe I'd. Well, let's try doing this. Move Maybe that was my mistake. Maybe I was going to think I had to divide it in half. Probably an easier way to do this too, but you know. I can fight it anymore. I don't know why. I'm not going to fight it. This edge to this edge. 2 point. Eight. Four. Move the Y distance 0. You know what? That's close enough for government standards. I'm going to stop fighting this. So, what we need to do then is close enough for a tax return. With it. Okay, so we are way off on our hole, which is perfectly fine. We'll dial the one in down here, and then the rest of them should line right up. So let's see if we can get a dimension. Let's just make it the center of this hole. Well, I mean, I could. Okay. Could do some fancy math. Here we go again. The fancy mathematics. Whoever said there's going to be math involved? 9, and that is 3.4 millimeters. So, yeah. So what we're going to do is we're going to hide this garbage. Back to the sketch. We know we're 237. All right. And we need to come back a little bit. Minus 4 divided by 2. Oh. And new wrong button. Minus 3.487. Finish sketch. We'll clean this mess up when we're done. So let's show this guy. My goodness. We are not winning at all, are we? We're just having one hell of a time. Yeah, we can edit it. Yeah, it's okay. It should be about the same. Yeah, we figured it out. My God. Took us long enough. 6. There we go. Took us long enough. Yeah, but we got it. Oh. Here we go. All right. Beautiful, beautiful, beautiful. Okay. Woo. We've kind of fixed that a little bit. So let's go ahead and go back to that sketch. The radius here. Hide this body real quick. So I can pull that out. Body. So we can probably go 11. All right. Here's the sketch. So what we're going to want to do, let's hide this guy. What did I say that was 5 millimeters? 5, okay. I think what I can do is grab these guys into that length. This is why, first of all, have that void space there. There we go. This is fine. That extra roundness, who cares? That's fine. All right. There we go. Now we're getting somewhere. Now we're getting somewhere. Okay, now I'm understanding, because I've never really done this too much with throwing a step file in. I knew it could be done. Because one of the great things about Fusion, if you use the electronic system, the engineering system Eagle that's built in, they work together. You can do things like this to create boards and then create your enclosure on the board. So I know it can be done. I've never done it before. But so we have alternative ways we can do it. We can do it with Circuit Studio by exporting the step file, do it with KiCad by exporting the step file, and basically designing around it. I'm just going to keep that open, that tab, because we're going to probably use that to design the lid. But this video, we're kind of running out of time. But that's fine. We're going to keep going as long as we can. So now I want to hide this. So we're going to take let's grab the top. Create a sketch. Because what I want to do is we're going to just put it there. This to here, and this guy to here. Sketch, and then what we're going to do bring up 1.6 millimeters. Basically, comes to the top side of the board, and then we can start designing the top the rest of the enclosure around that. But before I get too far ahead of myself, let's go ahead and that. This guy again. Let's go back to these guys. Create a sketch. Be oh, I hate how you're doing this. All right, get these guys equalized. So these will be the holes for the heat set inserts. So grab the dimensions of these guys real quick. 4.16. So we want them at least maybe just 4, basically 4. Okay. And let's just kind of make sure that'll probably be a driven. That's fine. 2, 4, 6. I just want to make sure that these guys line up 100% too. Because it's real easy to eyeball it. And have them not line up perfectly. Oop. All right, there's that. Finish that. Grab the insides of these guys because then it's going to be our countersunk basically for the heat set insert, and then the basically the thread length of the standoffs that we're going to use. So these standoffs have a thread length of approximately 6.6. So we're going to extrude. And that should, because we have a 3mm plus 5, we have 8. So we have the extra distance to shove that down. We could always bring the extrusion up just a little bit higher to account for it, but we'll see. We'll see how if we have to fight it or anything. It may not be a bad idea to bring this extrusion up because it should base everything off of this. So that should be 5. Let's go to 6mm. All right, there we go. So you know what? Let's go on file and save this. TMF projects. Let's go. Board. And we're going to just name this board box. All right, so that's going to be the lower box. So what we need to figure out, since we're going to be using standoffs, I figure the lid can probably actually contain the rest of it. This will be just the base box, which is kind of cool. What I can do then is go ahead and hide this. Go ahead and grab this. Stepper box base. All right. So what I could do is I go start, maybe, hold on. I want to do one more thing. So one of the things I almost kind of forgot about is we have our base here. Think about that. I kind of forgot that I want to be able to give it a way to mount to something. Now, there are other options we can take in the future, but I think we can do this. Make them equal. We'll grab these guys, make them equal. We can go these guys. I think. Actually, so let's try this. Grab that guy, grab that guy, or make them equal. So then if we do a dimension here, we're probably going to do like maybe a size for like an M3 hole to 3 millimeters. So we can probably go ho 10 millimeter by 10 millimeter. And then we can throw these are going to be a little bit harder to set up, but that's fine. Grab the holes. Equal them. Grab that. We're going to dimension that. We're going to 3.25. Make sure there's enough room in there. 5 by 5. I forgot kind of like mounting feet. All right, sketch. Now what we need to do is go back to it, show it, and I think that's this guy. Grab that, grab that, grab that, grab this guy. Wait, what the heck just happened? Yeah, what? You know what? Forget it. I'll just. No reason to fight it. No reason to make things more complicated than they have to be. Now, I don't know about you guys, but with things like this, I don't really necessarily like sharp corners. Don't necessarily like them, so we could fillet them. Fillet of fish. 2 millimeters should be fine. All right. All right, let's take nope. All right, look at that little guy. All right, save that. To file, 3D print. Okay. Save it. New downloads. I'll move that over once I know it works. So we're gonna hold it. Boo. Go ahead and print this out and kind of test it, and then tomorrow we'll kind of get a good look at it and see how it looks, and then we'll start designing the lid to sit on top. Now that the heavy lifting is done, it'll be a lot easier. Stepper box base, all right. Really basic. Circle on that. Okay. All right. Before I get too far, project. Or I mean, everything's gonna be better organized when I throw it up on the because it's gonna have. I'm gonna add another plate for the lid and stuff. But you know, for here, we're just gonna have this. We're just gonna leave everything the same. A little under an hour, so I'm gonna go and shoot it over real quick. A1, bam. So I'm gonna go and end the video here because we're not gonna see another 48 minutes while we wait for this thing to print. I'll print it, pop it off, see how it fits. If it fits good, maybe I'll go and throw the I might go and throw the heat set inserts in, just see how they fit. Secure the board down, and then maybe kind of try to show it tomorrow. Just using my phone camera real quick before we start designing the lid. So that's what we'll do. We'll get that printed out, and I'll see how that looks. If we have to make any adjustments, we'll have to make adjustments. Maybe I'll try doing that. That way we have a size that works, that the board can drop right into. So I'm really hoping for that, that we can just drop this guy on here. I see a place that might be an issue, but I'm hoping not. Because there's some of the TVS diodes on the bottom of the board that might be a little close for comfort to the one in mounting holes, but we'll find out. We'll make adjustments, we'll clean up, and I'll print on another if it does look to be that way. And again, this might end up being ABS in the long run. I might just go and I'll worry about that down the road after we do some more testing with it, because obviously there's a lot more to do. So yeah, I kind of want to design it so then the lid, the way the lid will sit on top is it'll have the walls in it to help, support everything. That way, when you pull the lid off, you have easy access to all the components and the test points, and it can just sit in the board. The only thing you have to worry about working around are the standoffs. So that's kind of the goal. That's why the lid's going to have the walls on it rather than the base. And it just, just give it kind of a different look. And who knows, maybe down the road, when I go to sell these, maybe I'll sell a couple different versions, basically for price points. We'll see. To try to make it a little bit more affordable, because again, since I'm doing everything myself, I'm trying to manufacture everything in-house and control that myself and do all that. I have to recover all my expenses and my costs somehow, and I'll try to figure it out, get at least maybe try to get an ROI over like maybe 1,000 boards or something, and just look to the future that way. But we'll see. We'll figure all that. That's a problem for down the road, not right now. Because as it sits, I'd be perfectly fine if none of these sold. I honestly would be. This is more for me and what I wanted out of a project out of this. I'm getting exactly what I wanted out of it. Everything else is just icing in the cake, and I wanted to share the knowledge with the world as best as I can. And just the experience of doing this in case, you had an idea of doing this. So, you wanted to try something similar for yourself. So there's other design things we can do with the enclosure, maybe like add-ons to it to maybe take this base idea and design even an add-on that this can like bolt to so it can clip to a din rail. You know, we'll work with it as we go. They could be little add-ons. That way you can clip this assembly to a din rail. Maybe something that this can sit on top of, and then you kind of screw it here to a din rail or to the din rail adapter, and boom, you can snap to a din rail. So we'll see. We'll see what we can do. There's a whole bunch of ideas. That way you can throw this on like with the PLC board or something like that. So, hey, we'll see what we can do. Thanks for hanging out with me. And again, stay safe with these winter storms coming through. Do everything you can to protect yourself. Try not to go out in it, especially in those places where you're supposed to get ice. I've lived through stuff like that throughout my lifetime, really bad winter storms, and I know it's not pleasant. I'm more worried about you guys that could lose power, especially some of the prediction that you could lose power for days or even well over a week, depending how bad the ice storm gets. So get prepared, get safe, and stay safe. And try to avoid going out in this mess at all possible. So take care, good luck, and hopefully see you on the other side of this. Have a good evening, or a good rest of your afternoon too. Take care.